Hello and welcome to the next set of this video series on Module 4. I'm now going to start talking about Chapter 3, which covers local file system security for overall Linux system security. Now, some of this we've actually dealt with before, simple stuff like looking at files and permissions, and then we're going to go into a little more depth on things like ACLs and setting up SELinux mandatory access control using metadata and things like that. So let's get started. We'll even talk about things that we talked about in class in Module 3, like LTAP, using that specifically for user authentication. So we're going to talk about using viewing file and directory details with ls, the list command. We're going to use chmod, chown. You can even do chgroup. We're going to talk about using ACLs to access those, to control access to files, getting them and setting them. We're going to talk a little bit about SELinux. SELinux is a significant component of overall Linux security. A lot of modern systems have SELinux running on them in ways that make it a little bit more difficult, honestly, to interrupt a Linux box's boot process and kick it directly into single user mode. I used to have to, actually I've done this more recently because honestly, I'm good at forgetting passwords. I've locked myself out of my own Linux box a few times. And one of the things I learned back in college was, hey, Linux has this thing called run levels. And one of those run levels is single user mode, where root is the only user. And you don't necessarily have to authenticate as root. So if you know you can get into run level 1 as the root user without the root password, you can obviously take complete control of the system, even if all you're doing is to reset the root password for yourself because it's your own and you haven't booted it in 3 weeks and have forgotten. I did the same thing to myself much more recently with Fedora. I believe the box was running Fedora 24 at the time. And I tried to do the same thing because I knew it used to be possible. I was running Fedora 7 way back when, and hey, Fedora's Fedora, theoretically. Except not, because... Okay, so, I misspoke there a second ago. I was not running Fedora 7. I was running Red Hat 7. And when I say Red Hat 7, I don't mean Red Hat Enterprise Linux 7, which is fairly recent. I mean Red Hat 7, which was released in the year 2000, running kernel version 2.2.16. Red Hat Fedora 7, on the other hand, was released in May of 2007. Before that, it was called Fedora Core. So the nomenclature has changed over time. And it was running... it used GNOME 2, KDE3, and kernel version 2.6.21. This was called Moonshine, back when Fedora had code names. The more recent version of Fedora that I'm about to talk about is Fedora 24, which came out in 2016 using kernel version 4.5. So there's a great deal of difference between Red Hat 7 and Fedora 7 and Fedora 24. And now Fedora is up to 31 and actually may have just come out with Fedora 32. I haven't actually upgraded to it yet. I will probably do that later this week, and I might even try a video about it as well. So, just a little correction on what I just said that was wrong, and now back to the rest of the video. Because they had put SELinux in an enforcing mode, and it prevented you from logging in as the single user without the root password. So you have to do some things about how it boots itself by changing grub. I am not going to do a demo of that, but there's a Fedora online magazine which has an article about it, which I have used repeatedly. We're also going to talk about file handling with move and copy, and finally LDAP configuration on your Ubuntu server. Now, this time around, because of the schedule crunch we're under due to the coronavirus pandemic, I'm not requiring the LDAP lab, but it is in Chapter 3. If you want to read it and try to do it, go for it. We talked about it in Module 3. If you really want to learn this, try implementing it yourself. So let's talk about the ls command. Now, this should be good and familiar with you, for you. We dealt with it in Module 1. We dealt with it in Module 2. There's information in it in the Linux Basics for Hackers. There's more information in it in Chapter 3 of Practical Linux Security. They touch on it on the Yellow Book, Kali Linux Revealed, Debian Administrator's Handbook. There's stuff about this in all of our resources. So basic stuff. If you want to look at long file information, including the mode block, -L. If you want to see what's hidden, -A. If you want to see human readable file sizes, say for example, if you do ls-l, what you get is the size of those files in bytes. And then you have to do the math. Okay, how many kilobytes, megabytes, gigabytes is this? Or you feed it ls-lh. -H lowercase is frequently with, and not with all commands, but with a lot of commands, is the human readable flag. So it'll tell you that the file is 10 megabytes or 1 kilobyte. It'll say 1 kilobyte instead of 1024 bytes, or 10 megabytes instead of some multiple of 1024. If you only want to look at directories, ls-l */. Now, */ will tell you only see the directory name. Say, for example, if you're down on your root directory and you want to make sure that, if you're down on your root directory and you want to make sure that there's nothing else hiding there, this is what you wouldn't do. If you wanted to look at the list of all your possible directories, say in Etsy or Proc or wherever, so you can figure out where to dive in on something, you could do this. You could do a recursive listing, the general format. There are lots of different ways to use this thing. And you can also use the alias command to add things like color auto. Another fun one that I've showed y'all in class is the -F flag. The -F will actually append a character at the end of these file names. So if you're on a system which can give you full color, great. You can set the color auto flags, and you'll see the directories in blue. You'll see the symlinks in light blue. You'll see the executable files in green. You'll see the plain files in white. But if you're not on a system that can do those colorations for you, you can generate the same kind of metadata, or display rather the same kind of metadata by using the -F flag. So it'll put an @ symbol after your symlinks, a star or an asterisk after your executables, a / after your directories, and so forth. It's very useful. Now, let's talk about the mode block. The mode block is this thing you see, these 8 characters at the beginning of every file readout in a long listing. You'll see user permissions, user owner permissions, group permissions, other permissions. And those fall into 3 categories: read, write, and execute. That first that first column will show you whether it's a link, a directory, a block file, a character file. If you see B or C, it is a device, either block or character. If you see D or L, it's a file of some kind, a special file. A directory, which of course is a file which contains other files, or a link, a symlink, or actually a link, either sim or hard. Symlink is a soft link. A hard link is two files which the same file showing up in two different locations on the file system. The command to change this is chmod or chmode or change mode. And it works, and basically when you do that, you can change how it works. You can add permissions, you can take them away. You can even work with special permissions like, say, the sticky bits, which we are not really going to get into. So let's talk about file ownership. There's a couple things you can do for file ownership. Okay, and actually, when you're using the chmode command, there's actually two different ways to do this. You can use your symbolic representations and your permissions, say u plus r, to give your, well, honestly, if it's yours, you should be able to read it. Say, for example, you want to make your own file executable. You could do chmode u plus x and then the file name, and that would make that file executable for you, but not for your group and not for everybody else. Say, on the other hand, you want to make the file executable for everyone. Say you've written a new batch file and you're very proud of it and you want everyone else to use it. You could do chmode a plus x, all plus execute, and everyone would have file permissions on it. Or, for example, say if you want, and you can also do this numerically, because each of these permission values has represents a bit in the mode block, and it has a value based on the binary position. Read is 4, write is 2, execute is 1, 0 is no permissions whatsoever, or you're locked out. So if you wanted to take full control of your file and deny complete control of it to everyone else, you could do change mode 700 on the file name. So your group could see it but not read it, or write to it, or execute it, but you have full control of it. Alternatively, if you want to give everyone the ability to read and execute your file, but only you can read, write, and execute your file, you could do chmode 777. Hi, it's me again. I realized as I was rewatching this video that I made a misstatement which could be fairly, which could lead you to make an important mistake. I was talking about the numeric codes for chmode. I was proposing the notion that you might set a file, read, write, execute for yourself, and read, execute for the group and everyone else. Say, for example, in the example I was using before, you've written a new bash shell script. And it's very cool, and you want everyone to be able to read it, and you want everyone to be able to write it, but only everyone should be able to read and execute it, but only you can write to it. I said that you could do chmode 777, but chmode 777 gives full control to literally everyone, and that's a bad idea. The command the numeric code to have full control for yourself and read execute for everyone else is chmode 755. Thanks, and thank you for letting me interrupt myself. Now, so there's a lot to do here. If you've worked with this before in our previous modules, this should frankly be a bit of a review for you. And let's see. So let's talk about access control lists. Access control list will show you another view of the same kind of permissions. You can either set them or get them with a set file ACL command. Set FACL. You'll say provide the group a group called user1 has read, write, execute permissions. So you could give, now every file belongs to one group and one group only. But actually, I skipped this, didn't I? Oh, let me fix this. The ACL thing won't make any sense if I don't explain this. Now, what you can do with a file that you own, or that a file, or as root can change anybody's file ownerships for anything. But for a file that you own, say for example, you're a member of 2 or 3 different groups. Say you're a project manager, and you're managing a software development project, and you've got some engineers, and you've got some testers, and you've got some developers, and you want to move a file from a group of, so that it stops belonging to a group of developers and starts belonging to, I don't know, a group of testers. The simplest way is to change the group ownership of that file with either the chown or chgroup command. Now, the thing here is you can do one of these things or both, or the other of these things, or both at once. If you're just changing the ownership of the file, you use chown. If you're just changing the group ownership of the file, you can do chgroup and name the group that it should now belong to, and then the file. You can also do the same thing, both things at once with chown by providing both the user owner and the group owner. And then Linux will look at who's trying to get into the file, who are they, what groups are they in, and what permissions do those groups have. Now, you can provide more granularity by using access control lists. So you've got, every file has one user owner and one group owner. But you can add permissions for other users and other groups, like this. Say, for example, to give the group user1 read-write execute access on this file, you do set FACL. So it belongs to the root user. The group can read-write only, read only, but group user one can read and write and execute. You can also you can set these. You can even determine whether it's possible with TuneFS. Give it the mount path, look at its options, and see what is available there. You can also look at those permissions and copy them someplace else. Say, for example, you're trying to do an audit of other people's access permissions. You can pull all that out, drop it into a file, and look at it later. Now, in terms of, actually, let me be right back. I'm about to run out of time, and I want to talk about how to handle files. So, be right back.